Okay, today we're talking again about multiple representations, and that just means describing the same concept, the same relationship using a table, a written format, an equation, and a graph. And today we're really going to focus on, if they give you one, completing the other three, and then identifying slope, y-intercept, and the proportionality of the situation. So we're going to start with number 1 here on your notes, and we're first going to be given a table. And we need to create a graph equation and a verbal situation. So to do this, we can easily go from a table to graph just by plotting those points. So that's what I'm going to start with here. To plot these points, I'm just going to remember that this is x, that is y, and then plot accordingly. So it's 0, 0, and then at 1 it jumps to 2 and 25/100ths, which is in between those two lines. At 2 it jumps to 4 and 5/10ths, 3, 6, and 75/100ths, again between two lines. 4 it's up at 9, 5 it is at 11, and 25/100ths right there. So we plotted those points. Obviously, if 10, we're at 22.5, that's off the graph here, so I don't need to plot that. Now we're going to look at the equation portion. And the way we do that is we're going to identify the slope and the y-intercept. So y-intercept can be found right here in our table. When x is 0, y is also 0. So I'm going to add down here, what's the y-intercept? It's 0. Then to find slope, we've talked about this before. We find our change in y, which is plus 2 and 25/100ths, over our change in x, which is plus 1. And that's going to give me a slope of 2 and 25/100ths. Then I plug that into y equals mx plus b form. And I get y equals 2.25x as my equation. Then I'm going to describe that verbally. And you can use any sort of situation as long as you're multiplying your independent variable by 2 and 25/100ths. So that could be Bob, I know it's super original, pumped 2 and 25/100th gallons per minute. And that could describe our relationship in words. So is this situation proportional? Well, our y-intercept was 0. It goes through the origin. We're not adding anything to our equation, and there's a constant of proportionality. So yes, this is proportional, and you can use any of those reasons. So I'm going to write y-intercept equals 0, because we were able to see that from our table, which was originally given to us. Now let's look at number 2. So chart number 2 gives us the equation, and we have to create the other three. So if my equation is y equals 1/2 x plus 4, I'm going to start by creating the table. That's what I'm going to jump to first. So these are my x values, these are my y. A really easy way to get my y values is to plug in 0 and figure out the y-intercept, which we know from the equation would be 4. And then you're just plugging x into this equation over and over. So if I do 1/2 times 1 plus 4, I'm just really adding 1/2, so that's going to be 4.5. And then it's going to add another 1/2, because that's our rate of change, so 5. Add another 5 and 5/10ths, and then 6, and then 6 and 5/10ths, and then when we get to 10, we really need to plug it in. We can't just add another 5/10ths. So if I think about it, 1/2 times 10, well, that's 5. 5 plus 4, that's 9. Now I have my table values, and I can easily come over here and graph the situation. So my y-intercept is 4. So when x is 0, y is 4. When x is 1, y is 4.5. When x is 2, y is 5. We continue going up by 5/10ths over 1, up by 5/10ths over 1, and then we're going to jump to 10 and jump up to 9. and I'm going to graph it correctly. So I'm going to jump up on 10 to 9. Okay. So there is our graph. And then your verbal situation must have a constant of 4. So maybe that's an entry fee, and then a constant rate of change, or a rate of change of 1/2 or 5/10. So I'm going to use, once again, the Bob situation. So Bob owns a gym, and he's doing it for the good of the community. So Bob's gym has a $4 startup fee for your membership, so has a $4 start fee, or membership fee, or whatever you want to use, and charges 50 cents per month to be in the gym. So and charges 50 cents per month. You can write whatever sort of situation you want, as long as it has a rate of change of 5/10 and a constant of 4. Then for our slope, we can pull that straight from our equation. We know that this is y equals mx plus b, or slope-intercept form. So my slope would be 1/2, and my y-intercept would be positive 4. Is this situation proportional? So we're going to check those things. Is the y-intercept 0? Is it not adding or subtracting anything to our variable? Is it going through the origin? Things like that. And in this case, all of those answers lead to no. It is not proportional. And you can use a variety of reasons. I'm going to say does not pass through the origin. And then I am going to move on to number 3. All right, for this one, they give us a graph, and we have to create verbal, equation, and table. So for this one, the table's fairly easy to make. We're going to look at 0 for our x-axis and go up and see that our y value is 3. So when x is 0, y is 3. When x is 1, y is at 3 and 5/10. At 2, y is at 4. At 3, y is at 4 and 5/10. Again, we see a pattern. 5 is at 5 and 5/10. And then we can even kind of see on this edge of the graph that when x is 10, y would be 8. Okay, from this table, we can find our equation by doing the following. We know that when x is 0, y is 3, so that lets us know our y-intercept. Then I can use it to find slope. So my change in x is 1, my change in y is 5/10. So when I do change in y over change in x, I get 5/10 over 1, which is the same thing as just 5/10. So our y-intercept's 3, our slope is 5/10. We're going to plug that into our equation using slope-intercept form, and we are going to get y equals 5/10 x plus 3. Then we're going to write our verbal descriptions. Maybe we want to use a video game example. So we're going to write Alpo starts with 3 XP, or experience points, and gains 5/10 XP per takedown. That verbal description, however strange it may be, has a constant of 3 that we are adding to our multiplied variable by 5/10. And then when I look at this, if it's proportional, if this situation is proportional, the answer once again is no. And from our graph we could tell because it doesn't pass through the origin. From our equation we can say no because we are adding in our equation. So adding in equation. And then we're going to look at number 4. If you want to try this one on your own, it gives you a verbal description and you have to fill in the other 3. Target sells apples for 45 cents per pound. So from this, I can tell that we have some number of apples, so pounds of apples, and that's changing. So pounds is my X value, and my Y, or my dependent variable, would really be the cost, because there is a money aspect here that depends on the amount of pounds of apples you purchase. So if I buy 0 pounds of apples, I'm going to get to pay $0. It's a wonderful concept. But if I buy 1 pound of apples, I'm going to have to pay 45 cents. If I buy 2, it's per pound, so 45 cents times 2, because I bought 2 pounds, 9/10 or 90 hundredths. And then you kind of notice that as we add a pound, we add 45 cents. And that's how we can fill in the table up to this point. Then we think of, well, 10 times 45 cents, we get to shift that place value and write $4.50. So if you look at this, you could find the slope, or you could just notice that each time our Y is changing 45 hundredths, and it's being multiplied by our number of pounds. And that's the relationship that is occurring. So Y equals 45 hundredths X, with X being the pounds of apples, Y being total cost. So we have our equation and our table completed. Now let's focus on the graph. And once we have our table, the graph is easy peasy lemon squeezy. At 0, our Y value is 0. At 1, it's going to be 45 cents. To 90 cents, we go up 45 hundredths, write 1, 45 hundredths, write 1, and we continue here, 5 being 225, and then 6 pounds we can end with. Following that pattern, it would be 2 7/10. So there's our graph. So now let's look at what is the slope. What's the constant rate of change? What's our constant here that's being multiplied by our variable? And that would be 45 hundredths. What's the y-intercept? Well, right here in our graph, we can tell when x is 0, y is also 0, or our graph goes through the origin. And if our y-intercept is 0, or our graph goes through the origin, or we're not adding anything to our multiplied variable, then yes, we can safely say this situation is proportional. Now I'm going to write y-intercept equals 0 as my reasoning. You could also say we're not adding. You could also say passes through the origin. Many different ways you could describe the reasons why this is proportional. And those are our notes. Please make sure your notes look like mine, and we will practice this in class tomorrow. Have a great rest of your day. Make sure this goes into your binder.